Hello, everyone. So we have a review video in this case. So I hope this is going to serve as a either a review after the test or just prep for a test about the circles. So the first question we have is like we are given the center of the circle. We have some lines or segments are given, and we just want to name those. Okay. So the secant line, like if you remember secant line, the line that touches the circle at two different points. If you look at the H like N, so this line is touching the circle at 2 points. So I can go with HN. So let's go ahead and do that. So the HN. So I didn't say LM because if I say LM, so it's just between 2 points on the circle, and that is actually called a chord. So the A, like L to M, is going to be chord, or M to I is also a chord. So I'm going to go with MI. So the chord is just a segment, part of the line that is on the circle when you connect 2 points. Like this is a point on the circle. This is another point on the circle. When you connect 2 points that is on the circle, the segment that you get is called chord. So MI is one of them. And even like F to M, this is the diameter of the circle. FM is also a chord. So that is also considered as a chord, which is the longest chord. And the tangent, the line that touches the circle at single point. So, this is the point of intersection between this KJ and the circle itself. So that's why the tangent line is just the line that touches the circle at only one point is called tangent line. So that was just the definition of the some terms. You may change these now, like based on the given figure. So I could just maybe choose instead of HN, like HN is a secant. So I think there is no other secant, to be honest. That's the only line touches the circle at two different points. So some people may claim, how about MF? MF is not a line, so it's a segment. Okay, so that's why I wouldn't choose as a secant line. And for the chord, I could choose MF, that's also a chord, or ML is also a chord, but nothing else is actually chord in this figure. And there is only one tangent line, which is I chose already. Okay, so that's the first problem. The second question is asking, find the equation of the circle when the circle passing through is 0, 5, right? So it's center at origin. So like what we want to remember before we kind of try this one is the equation of the circle. Equation of the circle is x minus h to the second power plus y minus k to the second power. And this is equal to radius to the second power, right? But in order for us to do so, we need to know the center, which we are told that is origin. So which means the h comma k is our center of the circle, which is we are given as origin. So I'm going to choose that's 0, 0 for x and y. So that will be x minus 0 to the second power and y minus 0 to the second power. But the question is, how do I get the radius? Like we know the center, but there is a point on the circle that's 0, 5. If you want to draw this picture, your point, the given, is gonna be 0, 5, which is your y value is 5, x value is like 0. So like if you draw a circle, you are gonna see the radius is actually 5, which is kind of obvious in this problem. But in some cases, we have to use the distance formula. But in our case, it's like this. So we have a center at 0, 0, and then this is 0, 5. How do I know? Because that's given passing through 0, 5. So 0, 5 is right here. So this is 0, 0. And the distance between these 2 points, the center and the point on the circle, is just 5 units. So which is why the radius is 5. But I need to write r squared, which is going to be 5 squared. Okay. So that is my equation. But x minus 0 just x. So I can go with x itself. So the x squared. And then plus y squared, same as the other one. Y minus 3 is just y. So and then 5 squared will be 25. So you may just leave it this way for the equation. And for each point, decide whether or not it's on the circle. Like in order for a point to be on the circle, it has to satisfy the equation of the circle, like that you are given. So if you plug -2, for example, for x, let's do that. So like if I plug -2 for x, so you should get x squared, right? So that is -2 squared plus y squared, which is root 21 is my y, and then you square this. And if this is equal to 25, then we are going to say yes. So -2 squared is just 4. And then square of root 21 is 21. If you square a square root, so the square and radical will cancel, you got 25. So which is why I will go with this is yes. And similar reason, if you take the square of the x, so you will get square root of 21, which is square, and plus 2 square. And this is 21, and then this is 2 square is 4. So if you add them, so you get 25 as before. So which is why that is also on the circle. And if I do the same thing with the next one, so 0 square and -6 squared, this is equal to 0, this is equal to 36. If you add them, you got 36, which is not 25. So I will say it's no. And if I choose 50, so that will be okay as well. So you can just check by adding the squares. So that is also 25. So for that reason, that is also good. Okay. So you just plug the the numbers into the equation that we have and see if that satisfies. If that's the case, then that should be on the circle as well. Okay. So that was the number 2. So let's look at the next one. So we are given EG is a diameter. So E is right here, G is diameter. Suppose that the arc EF is given. So EF, so let me see. So this arc is given, right, as 64. And the first thing that you need to remember, like whenever you have a arc, okay, this arc is like endpoint is E, endpoint F. If you draw a like chord from the endpoint and chord from endpoint, so they're intersecting at G as inscribed angle. And the inscribed angle is going to be half of this angle. So I'm just going to remember this feature. So the inscribed angle will be half of the arc that is opposite. And EFH is 63. So EFH is given 63. So EFH. So they are talking about the angle in between EF and FH. Okay, so that is 63. And this is also inscribed angle because that's in between EF and HF. So that's inscribed angle. And then if you double that angle, so you will get the arc measure that is going to be twice of this 126. So let's look at what's being asked. FEG, so we are looking for FEG. So we need to know this guy, right? So that's what we are looking. And GFH, GFH. So, and then also we are looking for this angle. So one of the things that we should probably remember, whenever you have like a diameter, because we are told this is like diameter is EG, diameter will divide the whole 360 degrees into two 180s. That means the EFG, the arc measure of that angle is going to be 180 degrees. So if you start from E all the way to the F to G, that's 180 degrees. But we know EF is 64. So if I subtract 64 from 180, so you will get like 116 for this piece. Okay, so that arc will be 116. And G is the endpoint of that arc, and F is also another. So if you draw the chord from F to like the intersection, so that will be this angle E is our inscribed angle. If you remember from the first two example. So this guy, like what I mean by 64 and 126, this inscribed angle was the half of the arc measure that is opposite, which is 116, should be divided by 2. So if you divide 100 by 2, you get 50. 16 divided by 2 is 8, so that means this is going to be 58. I mean, FEG, yeah, FEG is 58. And the second one, GFH, I'm gonna use the same reasoning. So since EG is the diameter, right? And then you can see HG, okay, which is my like arc, is equal to 180 minus 126, which is like, if you think this is 30, that's gonna be 50 left, so 54 basically, and you can just subtract. And this arc, H to G, is 54, but this arc is actually opposite this question mark as inscribed angle. So this inscribed angle should be half of 54, so that should be 27. So there is some other ways to do this problem. So if you remember some other features, but let me type these first. So this is what we want to submit. And like one another thing to remember was this. Whenever you have a angle that is opposite to the diameter, which is AG is diameter, and that will be in the triangle. So the angle right here that is opposite diameter is gonna be 90 degrees. And since this is 63, so what's left over should be 90 minus 63, which is 27. So you can just get that immediately without really doing the process I did, okay? But I just use the definition of the inscribed angle in this case, okay? So let's look at the next one. So the question we have now are asking some sort of angles. So if you kind of remember, we do have angle relation when two secant lines are intersecting outside. So if two secant lines are intersecting outside, which is this angle, and the angle somehow relate to the arc measures. Okay, so like if you think about this secant line, and then this is intersecting at two different points with the circle, and same idea with the other circle intersect at one point, right? So the relation between this angle in between two secant line when it's outside, so we are gonna remember that is equal to difference between this the smaller arc in between the intersection and the longer one. Okay, so then W all the way to the this one. So if you take this arc and subtract this red arc, then that is gonna be difference. If you take that half, then you will get the angle outside. So let's try and see how this is gonna be look like. So VW, so VW is given 172. So this is 172. Okay, and VX, so VX is 50. So the red part is 50. And VYX, which is this R angle, is gonna be, I'm gonna call this is like equal to the difference between these two angles, 172 minus 50 divided by 2. So again, if the two secant lines are intersecting outside and the angle in between two secant line is half of the difference between two arcs of the intersection with that two secant line. So 172 minus 50 is going to be 122 and divided by 2, which is 61. And that is my answer for this part. Okay, for the second one, the second question, like quite similar to the first one, but only difference is now, like they are not intersecting outside. So the intersection inside, like when you have two chords inside of secant line, intersecting inside, the angle in between those two chords, let's say like this angle or this angle, based on the angle we are gonna kind of talk about it. So that will be half of the sum. AEB is 73. So the AEB, which is this angle, is 73. Arc AB, which is this angle measure, is 104. We are looking for CD. So like this 73, like what I mean by that, so the 73 is the angle in between these two chords. So this arc angle is opposite to this arc. And since this 73 is the same as this one because they are vertical angle, and that angle opposite to this arc, so the angle in between those two chords, which is 73, is equal to average of those two arcs. So 104 plus CD, okay, and divide by 2. And if you get this equation, you just like want to find this unknown. So maybe we can multiply both sides by 2 to get this get rid of this 2. So which will give us 146 equals 104 plus the angle measure of CD. So if you subtract 100 from both sides, you get 46 and 4. So if you subtract another 4, so you will get 42 as your angle measure of CD. And that is my answer for this question. Okay, so let's do another problem. So we have given equation of a circle, and then we like to find the radius and center. Just to remember, like x minus h to second power plus y minus k, okay, to the second power equals r squared. This is the equation of circle. So, and then the number after the minus sign, which is h, is our x coordinates of the center of the circle, and the number after minus sign, which is k, is the y coordinates of the center, okay? So that is our center of the circle. And the r is just the radius. So in this case, there is no negative, right? So in this x plus 5, but I can write this as x minus 5 to the second power. And then this second one is y minus 3 to the second power. And this is like 16, which can be written as 4 squared. So some people are missing this part. So you need to have a negative sign in between the x and the h, because you are going to take the difference between x values when you actually get this in the first place to get this Pythagorean like this in between two x coordinates. So which is why we need to have a minus, but this wasn't there. So we just wrote it this way. And this number, -5, is the x coordinate of the center. And the number after the minus sign, which is 3, is my y coordinate. And the radius is just the number 4. So then that will be 4. So let's plug this into, and then I'll graph as well. So radius is 4, and that's -5, and this is 3. So since we want to know -5, 3 as the center, right? So let's go ahead and plot a point. So I will go with -5, 3. Okay, so that looks good. And I will drag my circle here. And then since my radius is 4 units, so I can go with, this is 2, this is 3, this is 4 units. So I think, let me double check. Yeah, that looks good. Okay, so that's the graph of my circle as well. Okay, so I hope that 5 question was helpful. So I'll see you in the next video.